Evaluate the indefinite integral e to the t over 1 plus e to the t dt. Observe that the derivative of e to the t is also e to the t. And so we will let u be 1 plus e to the t because the derivative of 1 plus e to the t is e to the t. We let u be the denominator, 1 plus e to the t. Then the differential du is 0 plus e to the t, the differential dt. We then substitute e to the t dt with du and 1 plus e to the t with u. With this, we rewrite the given integral. The numerator e to the t dt can be substituted with du. The denominator is now u only. And this is the same as the integral of 1 over u du. The antiderivative of 1 over u is ln of the absolute value of u plus c, but u is 1 plus e to the t, knowing that 1 plus e to the t is positive already, so we don't need the absolute value around it. And this is the answer. Now, how do we know to let u be the denominator but not the numerator? If we were to let u be the numerator, then du is e to the t dt, but then e to the t dt is not the same as what is left, which is 1 over 1 plus e to the t. Evaluate the indefinite integral of tangent of theta d theta. We don't have the antiderivative of tangent of theta right away, even though the derivative of tangent is secant squared, but this is the antiderivative of tangent, not the derivative of tangent. With any trigonometric function, we will rewrite this. Tangent is defined to be sine over cosine. So tangent of theta is sine of theta over cosine of theta, and we still have d theta. At this point, we observe that the derivative of sine of theta is cosine of theta, and the derivative of cosine of theta is sine of theta. We now have to make a choice here, whether we should let u be sine of theta or let u be cosine of theta, and we don't know which one. The easiest way to do this is just to do one and see if it works out. For example, if we let u be sine of theta, then the differential du must be cosine of theta d theta, but this is not the same as what is left. If we let u be sine of theta, then what is left is not cosine of theta, but 1 over cosine of theta d theta, and clearly cosine of theta is not the same as 1 over cosine of theta. And so, we should try to let u be cosine of theta instead. If u is cosine of theta, then du is negative sine of theta d theta, and we see that sine of theta d theta is what is remained after we perform the u substitution. That is, if we were to rewrite it, we would have the integral of sine of theta d theta is now negative du. And in the denominator, we're left with cosine of theta, and cosine of theta is u. This is the same as negative the integral of 1 over u du, which is negative ln of the absolute value of u plus c. But u is cosine of theta. We don't know whether cosine of theta is positive or negative, because it can be negative or positive, so we would need to use the absolute value around this.